told you, anytime you are converting decimal to fraction, first of all you divide it by 1, then you start shifting your decimal point. Now what we want to achieve here is to shift our decimal point 2 places forward, so that we can have it divided by 100, because if you can express a fraction in the form of over 100, then that is a percentage. So here we were going to have if I put this place 2 places forward so that I can have 2 zeros here, then I'll shift here also 2 places forward. So at the end of the day, I'm having 033. The decimal point has come out here over 100, and that is the same as saying 33 over 100. So my aim here is to be able to express it over 100, and that is the same as 33%. Now anything that is expressed over 100 is also in percentage. So this is what you've just done here. Now another question may be in the case of convert 0.148 to percentage. Okay, let's see. Solution here would be, remember, first step is to have it in the decimal change to fraction, which is going to be 0.148 over 1. Then I begin to shift my decimal points. All I just need to do is to shift 2 places forward so that I can have it over 100. Then this one also goes 2 places forward, so I'm having 0.148, because decimal point is now between 4 and 8, over 100, which is the same as okay, 0.1. That 0 is not significant. I can take it out, and becomes 14.8 over 100. Now I've expressed it over 100. Whatever it is that is expressed over 100 is the same as the percentage of that value. So we have 14.8%. So this is what you do when you are converting from decimal to percentage. First you convert it to fraction, then you express the fraction over 100, then you take the value in percentage. Now it can be reversed. Supposing you have a question like this: express 21% in decimal. Express 21% in decimal. This is simple. All you need to do is to what is 21%? It means 21 over 100, right? This is the same as 21 over 100, and this can be expressed in the form of decimal by trying to reduce the denominator to just 1, and that will be by shifting my decimal point 2 places backward, and I shift 2 places backward, and now I'm having 0.21 over 1, and that is 0.21 in decimal. So this is what I'm having in decimal. Take note of that. You can do it vice versa. Now supposing this man says here express 0.125 as a percentage. What we are going to have a solution here will become, first, 0.005 is the same as 0.005 over 1. That's the first step. Now we are going to shift your decimal to just two places so that you can have it over 100, and this also shift 2 places, so we're having 0.5 over 100. Well, all these 0 before your decimal point doesn't really count, so we're having 0.5 divided by 100, which is equal to 0.5%. So that is exactly what you're having in your final answer. So we can take more examples as possible, but just take notes. You have them there in your textbook. You can quickly solve for those ones.
There is a question here that says,
um a student, can I just take this off? Spend 37.5% of her money on food, comma 28.75% on rent, and 15% on books. What percentage of her money is left to spend? What percentage of her money is left? Now, the solution to this question will be that let's take the underlining factor here. A student spends 7.5% of her money on food, 28.75% on rent, and 15% on books. What's the percent of her money that is left? Now let us see. As a matter of fact, the percentage can be represented in fraction. So what we are going to do here is this. 37.5% is the same as 37.5 over 100. That's a fraction. All right. And the other case is that she spent 28, so 28.75% is the same as 28.75 over 100. Good. And the third one here is that 15%, which means 15% is the same as 15 over 100. So what this simply means is that each of these fraction represents a whole of the entire percentage. And what is the whole of the entire percent? 100 over 100. He has not spent up to 100 yet. He only has um, all these spent for various things. So I'll just take this way. So I have okay, let's see something first. They said he spends 37.5% of our money on food. So if I have the percentage, the part of the money that was spent on food, plus the part of the money that was spent on rent, plus the part of the money that was spent on books, plus the part of the money that is remaining, that's the leftover, everything will be equal to the maximum percent, because it's a fraction of the whole. And what is the whole percentage? Whole is 100 over 100. So we are going to have 37.5 over 100 plus, what is the second one there? 28.75. 28.75 over 100 plus what is the third one there? 15 over 100, 15 over 100, because this is the amount he spends on book, rent, and what's the third one there? What do you say the third one is again? Let's see. And what? And okay, spends on food, rent, and books. So this is the amount you spend on food, rent, and book. Now plus whatever is left, we don't know, let's call it x. Everything will be equal to whole, which is 100 over 100, because everything here is expressed in 100 over 100. Remember, if a child scores everything, that means he has scored 100 over 100, which is the highest percentage you can get. All right, this is going to become if I take a common LCM for this part, I'm going to have 100, which is the common LCM there. Then here I bring down my sorry, this is supposed to be over 1. We don't know the value of x. Okay, let's leave x in the first place. We don't know the value of x, so let's just, it's x we are looking for, so let's leave that out. And here we are going to have 37.5 plus 28.75 plus 15 over 100, which is this part that I've just explained. This is the part I just solved for now. I didn't include my x, I only solved for this part. Okay, so everything plus x will be equal to 100 over 100. Now let's see what the whole of this will give us. We can just quickly do some rough sketch here. We have 7.5, we have 8.75. Let's add this one up first. You have 5, you have 2 points, you have 16 right, and 6 carry 1, you have 6 again, so it becomes 66.25 plus the other 15 here, 15, which is 25, bring down a decimal point, 1 carry 1, 7 plus 1, 81. So that is what we are having. I just did that rough sketch so that we'll be able to know where we are heading to. 81.25. So I have the whole of this giving me 81.25. This is equal to 81.25 over 100 plus x is equal to 100 over 1. Now look at something here. If plus 81 plus 25, because there's addition is the sign binding these two values, so which means that the whole of this will have to cross equal to, and remember it has a positive sign. Okay, using the additive inverse property. So we are going to have here just x left on this side, so you have x will now be equal to 100. So this is supposed to be 100 over 100. Sorry about that. Maybe I'll just clean this off and write it out again. 100 over 100. So it becomes 100 over 100 minus, because this sign becomes minus. Remember, there is a positive sign here, although it's not showing. But as soon as it crosses equal to, it becomes minus 81.25 over 100. Now let's see what we are going to get. Which of them am I going to take off? Let me go to the next page. You have x is equal to 100 over 100 minus 81.25 over 100. Alright, this is a fraction that needs to be subtracted. Once again, we look for the LCM of the two denominator, which is 100. Still 100 into 100 times 100, you have 100 minus 100 into 100 times this, you have 81.25. You already know how to do this by now. This is equal to x, so I'm having my x to be equal to, let's see if we can subtract this, 100 minus 81.25. remember, I have to explain, put them in place value form. Now I'll call this, take 1 from here, borrow, and here it gets to this point, becomes 10. 10 minus 5 is 5. Here will be remaining 9 because you took 1 earlier. 9 minus 2 is 7. To bring down decimal points, here remaining 9. 9 minus 1 is 8. Then here will be remaining 9 also. 9 minus 8, you have 1. So you have 18.75. My answer will become 18.75 over 100. And what is 18.75 over 100? That means 18.75%. That's the amount that is left for the kids to play around with after he has bought his books, he has bought his clothes, and his feeding. Alright, this is what you do in this case. Now we may just want to look at one more example. Here it says example here. What is 30% of 180.90? What is 30% of 180.90? Now look at it. Off in maths means times. Wherever you see off in mathematics, remember board maths, brackets, which also means times, okay, off, which also means times, division, of course you can't divide fraction, but just leave it there, they work hand in hand, multiplication, that's times as well, addition, that's plus, and subtraction, which is minus. Now what we are trying to say in essence is that off means times. So when I say 30% of 180.90, what I'm simply insinuating is 30 over 100 times, off there means times 180.90, and that will be equal to let's see, we want to reduce this to 1, so we shift the decimal point 2 places forward, so we can shift this one 2 places forward. That becomes 30 times backward either, 30 over 1 times 1.8090. Now anything divided by 1 is that same thing, so what we are actually having here is 30 times the whole of this sheet here, which would give us let's see, 3 times 0 is 0. Have 3 times you have extra 0 here because of the 0 here. 3 times 9 is 27, write down 7, carry 2. 3 times 0 is 0 plus 2, 2. 3 times 8 is 20. 3 times 8 is 24, write down 4, carry 2. Come on. 3 times 1 here is 3 plus 2, 5. So if I'm going to count my numbers before this map, I have 1, 2, 3, 4. Now I'll take 1, 2, 3, 4. The answer is 54.2700. Of course, this 00 after decimal point, they don't count, so it's going to be 54.27 as my final answer. So we'll just squeeze this out into this space here, and that is your final answer.